Hello everybody and welcome to this new webinar in the webinar series of Asian Metallurgy. I would take a minute of yours for introducing this event and this webinar. Asian Metallurgy was conceptualized earlier as a ground exhibition and it continued to be a ground exhibition coupled with conference till COVID time. After COVID, we transformed all our events and conferences and exhibitions basically on digital platform and make from bi-yearly it was made a yearly event. So this Asian Metallurgy event consists of two things. One is a webinar series which we are conducting since yesterday, and the other is the digital expo, which is our try to give a near real experience for the visitors, and it will be open from 15th of December. So these are the two aspects of Asian metallurgy. And in the webinar series, we try to cover many aspects of metallurgical industry, right from digitalization to decarbonization to lead and zinc update from. And then one of the very prominent subject for metals industry, steel and metals industry, is auto. Why automobile industry is very important to steel and metals industry is that it is one of the very prominent customer industry for us. And the future of auto industry, in a way, future of steel industry and metals industry, casting industry, in a way depends at least partially on auto industry, because a lot of castings are being used in automobiles, a lot of steel in the form of body, steel body, and other parts, engine parts are used. They are made of steel parts, steel components. So to that extent, auto industry remains a very important industry for us, because the if auto industry grows, that effect is felt by the steel industry, and so vice versa. If auto industry goes down, that effect is also felt by the steel and metals industry. So this webinar, which is titled "New Trends in Indian Auto Sector," is very important to the metallurgical industry as such, and specifically to steel industry, and also alloy steel industry, and also the foundry sector. So this to that extent, as I said, this webinar is very important, and we have experts in the sector to share their insights and share their views about the future of Indian auto sector. And this session will be coordinated by Mr. Udayan Pathak. A word about Mr. Udayan Pathak. He has been in world class. What is that? World class uh, manufacturing. World class manufacturing in Tata Motors for a long
World class
time.
quality.
World class quality in Tata Motors for a long time, and then he is now chairman of ASM International Pune chapter. Is that right?
Past chairman.
Past chairman of ASM International Pune chapter, and he has been with us for a very long time. As far as auto industry is concerned, we look auto industry in a way through the eyes of Mr. Udayan Pathak. So none other than Mr. Udayan is coordinating this session, and now I will hand over the charge to Mr. Pathak.
Thank you, Mr. Chandekar, for such a decorative introduction of me. And I think now it has increased my responsibility. So thank you very much. Friends, we have, as Mr. Chandekar has said, through this platform, the most important thing, even if we talk about the, what is the steel's role and all that, first, the most important part is to understand how the automotive industry is moving globally vis-a-vis in India, and with a more focus on India, and then how our different agencies involved into it are getting ready, or what are the challenges uh, ahead of us in these areas. These are the areas which we are going to touch upon today. Also, what is going to be the scope for the innovation and its role, particularly materials innovation, etc. So that is the broad outline of this webinar. With this, today I have the co-host or co-anchor with me is Ruta Barve. Ruta is basically a materials engineer from College of Engineering, Pune. She had her first leg of her career with Cummins for a long time, and then she joined her family business with a father, and now she's first generation entrepreneur, and she's the founder of uh, Metal Consultancy Services, as well as co-founder of Pure Petal, a biodegradable product company. And with this background, Ruta is also currently the secretary of ASM International Pune chapter. So she is Ruta. Then we have Mr. Chandrakant Aute, who is also having a very good automotive industry experience. Basically, if we talk about Mr. Aute, he is currently uh, the vice president in a company called Octilion Power Systems. Uh, he's carrying almost 29 to 30 years of experience in automotive industry, in design and development, and extensively worked on the electric vehicle, hybrid vehicle, and basically he was quite actively involved into the integration of various multiple aggregates on the vehicle level. So that was one of the strength and one of the different perspective Mr. Avte can place in front of us. Then we have Dr. Sanjay Arore, who is again from College of Engineering Pune and IIT. He has worked in various automotive company, and he was instrumental in starting Symbiosis Skill University, which is at Bombay Pune Express Highway. And he is going to talk about, he's basically worked in various automotive OEMs. So international OEMs, I will say multinational OEMs. So he can give a little broader perspective to us. Then we have Dr. Rajkumar Singh, who is the Senior Director of R&D in Bharat Forge. He is the head of the Technology Center of Kalyani Group, which is at Kharadi. And he is also having a very wide experience, and he is actively involved into the various component and technologies that is required for the component development. So with this background, and I will talk a little bit about the innovations towards the end of this webinar. So with this, I hand over to Ruta so that she can take the proceedings further. Over to you, Ruta.
Thank you, then, sir. Good afternoon to all esteemed delegates and panel members and industry leaders. It is my honor to welcome you to this panel discussion. Panel discussion on new trends in the automotive sector. As Chandekar sir and Udayan sir already mentioned that automotive industry continues to be one of the largest consumers of steel, and its rapid shift toward lightweighting, EVs, advanced materials, and new manufacturing technologies is reshaping the expectations from this our sector. So today we'll explore the key trends driving this transformation, the material and processing innovations underway, and the challenges and opportunities ahead for OEMs, system integrators, and component manufacturers. So let us begin. To start with, I would like to request Dr. Arole to share insights on how do you evaluate the current momentum in the Indian auto industry. What are the overarching trends shaping the sector today? And one more point to add is we often speak about India becoming a global manufacturing hub for automotive sector. And in your view, what factors are accelerating this growth of this industry? Is it policy, supply chain maturity, or technology readiness? Over to you, Dr. Arole.
Okay. Thank you, Ruta. Yes, I think you have put the questions. Maybe I will come back to you because there are 2 or 3 questions are coming in. So let me take first how do I see a trend in the growth of Indian automobile industry as such. See, as all of you know, like any Indian or global auto industry is continuously undergoing different transformations. We have seen IC engine right from Bharat Stage 2 to now Bharat Stage 6. On similar lines, in the current scenario also, or in the future also, there is going to be a significant transformation in the Indian auto industry. If I consider why and how they decided to have this kind of a transformation, most of these transformations are driven by majority three factors. One, they are technologically driven. They are driven by regulatory requirements of the land or of the global requirements. At the same time, they evolve based on the consumer or customer perfections. And based on that, this auto industry is taking different shapes. Now, in the current scenario, majority of the things in the auto industries are circling around development of electrification or electric vehicle. That there I would consider both electric as well as hybrid electric. So this is happening, and this is also pushed by government because they have already the FAME 2. And at the same time, the PLI, that's productivity linked incentive schemes, are pushed by the government, which will help in growing this EV sector. Another aspect which is coming is to have a clean mobility and the sustainability. So maybe I can elaborate on this point at a later stage. Whether it's a EV or it is a petrol or fuel-driven vehicle, the 2-3 aspects coming up in the near future is going to be a connected vehicle. And that's what we consider as an autonomous vehicle. In fact, there would be some kind of regulations also in future. So accordingly, most of the auto industries are planning to introduce ADAS system like advanced driver assistance systems into it. There is also a possibility of direct connect with the customer. In the future, probably any customer will be able to order or select his car online on the sites floated by OEMs. That will reduce the dealer dependency. So this is the kind of a change is expected in the near future. This is happening considering the digitalization or digital economy which is coming. The auto industry is, or they have to focus on the safety and regulations part of it. Because safety is a prime concern of the customers or consumers. And there are definitely, all of you must have heard the stricter emission norms as well as the crash worthiness, the NCAP, Bharat NCAP, that is the crash worthiness concepts. You also have a possibility, or not exactly, but it has been discussed several times about shared mobility. Today in India, the large population of vehicles is in two-wheeler segment. And partly we do have three-wheeler auto rickshaws. And when it comes to the passenger cars, yes, it is always said the two-wheeler says the passengers are creating roadblocks. The passenger car driver says two-wheelers and auto rickshaws are creating roadblocks. So to avoid these kind of traffic jams and roadblocks, yes, there is going to be different models of shared mobility. You already have seen the shared mobility like Ola and Uber, which is at the same time, you also have at some part of India, you also have these two-wheelers also going in the similar fashion. One important thing is going to happen in the auto industry as such, not exact, truly just auto industry, but auto component manufacturers also. Because auto industry is struggling to get proper supply of components. Today, I think if not for anything, at least 10 to 20% of the components are still imported. And they would like to develop the localization and supply chain dependency. They want to increase in that sense. So from that point of view, particularly if I have to say specifically for EV, the battery localization is going to be uh, kind of it will have a major importance. Okay, and then you were asking like a global hub, right?
Yeah, yes, sir.
Yeah, see, from global hub point of view, after pandemic and other economic situations worldwide, the people are still considering there has to be somebody with something like China plus one. Not just, they don't want to just depend on China. They want to develop somebody who will be China plus one strategy. And from that point of view, worldwide, the global OEMs are looking India as a manufacturing base for their most of the export market. So particularly in EV, at the same time, they are also looking the talents available in India for doing their product development. Like we have the software development has been happening in India on similar lines, automotive product development, not just the mechanical product, even the electronic products. Those are also going to come in the near future. In fact, you might have heard that government of India has already put up the semiconductor development. I mean, that is on focus. So from that point of view, the global players are looking at India for developing both product as such, at the same time manufacturing. Not just as a OEM building a cars in India, but even the component industry, auto component industry would have a better and better opportunities for the future. That's what. For the time being, maybe I can take up some other points in the next questions.
Yes, yes. Thank you, Dr. Arore. That was really valuable insights in the new trends or where the future lies and what is driving it. With that, let's shift to our next point. Mr. Aute, could you share your thoughts on the from the system integrator and system manufacturer's perspective, the shift to EVs has placed immense responsibility on system integrators. So, what innovations are you seeing at tier 1, tier 2 organizations that stand out? And EV components and demand entirely uh, different material properties: thermal stability, crash energy absorption, conductivity. So, from that perspective, what are the challenges from the materials perspective which are being faced by you?
Thank you very much, and thanks Udayan for introduction and all team member. Thank Ruta ma'am. Yeah, so actually I'll just brief about myself so that I can answer well and people can understand. So actually I'm responsible right now for engineering, quality and service as a VP technology, and I'm mainly working in EVs and hybrids from more than a decade, I think 1.5 decade. So I'm very EV passionate guy and enthusiasm guy, and want to change as much as I can for a green revolution. If I can reduce some gram of CO2 in the on the road, I'll consider is my day. Okay. So coming back to your question, what innovations or what trends are coming? So I'll always go by the actually needs drives the innovation. It always is you know the crow, he puts the stone in the bottle and then water comes out. Actually, his need is that he is thirsty. Here, his need is that we have to go to emission free or lesser emission, green, renewable, and all. And then this need actually then it boils down to what I need to do to meet this. If you compare the ICE vehicles, ICE meaning internal combustion vehicles, the diesel, petrol, and the EV, electric vehicle, we call as a battery electric vehicle, it can be hybrid vehicles. To gasoline or the diesel, they have very high energy density. The fuel is very high energy dense compared to the lithium and battery packs. Okay, while lithium and battery packs, we say 200, 300 watt-hour per kg is really great. But if you compare it with the current one, the gasoline ones and diesel ones, it still far has to go. And at the same time, we want to give the range meaning one charge, how much kilometer I can travel from X distance to Y distance, so that you can do your daily commute or daily your whatever your objective of doing this. Okay. And another point is that EVs require more charging time to you. The refilling time in say in ICE world is more compared to. So coming back to this, that I need to package more energy. That means my batteries will be heavier with respect to the fuel tank. If my fuel tank is, you can say about 150 kgs, can give me a 10 times energy with respect to the 100 kilowatt of battery pack. I'm just giving analogy. So I need a more weight to carry to have a better or equivalent energy density or energy. Ultimately, what happens actually, you are converting electrical energy into the mechanical energy. In an ICE vehicle, it is a chemical energy into the mechanical energy. So I need to carry more the electrical energy. It is a chemical energy we are converting into the mechanical energy. It's a transition from one. To that drives, I need to have what is given to me is the lithium and battery pack, and people are working on the lithium cell, energy density improvement, shape and size, and all this thing. At the same times, on the metal side, or I'll say on the automotive side, I need to be on a lighter weight. How can I reduce my weight so that I can package more energy in the given footprint? Because you people may be aware that to carry, I mean, if you have more weight, you need more fuel and hence more energy. So I need to maintain the let waste as much as I can do. Another point is that you need electric vehicles. The battery wants to be in a best thermal equilibrium zone, which is about 25 degree to 35 degree. In ICE vehicles, the engine behaves better above 80 degree. Here, the battery behaves better in 25 to 30 degree. Okay. And the motor and all this thing, they also want to be better in 50 to 50 degree, not more than degrees. Meaning they always give a better performance. So my conditions are different. So ICE engines, they are happy about 90, 100 degree. I want 25, 35 degree. So what happens that you need to metals which can conduct the heat or dissipate the heat faster. Okay. One is lightweighting, other is conductivity. At the same time, some metal I need insulating, I need some thermal conductive material, I need some electrical conductive material. One of the best material in right now in EV is aluminum, which is right now is importance is growing and growing other than copper. Copper is more into the power electronics, but aluminum is actually into the, if I take a, let's say, example of battery. Battery enclosures, either you can make it in sheet metal, which is normal or E34 or DP5110, like this, or we can go to aluminum. Aluminum definitely reduces the weight. And in aluminum, you can go either aluminum extrusion, aluminum casting, LPDC, HPDC, then it gives a very good thermal conductivity. Okay. So aluminum is growing very well in especially the heavy industry because it is more machinable, better machinable, and lightweighting and thermal conductivity. I'm not saying sheet or DP or conventional E34 and other metals are not there. They are there, but in EV particularly, I'm talking about this. If you take a power electronics or a motor, so you need a stator, you need a motor, you need a casing. So casing is again coming into the aluminum casting because you need a water cooling in jackets inside. In a battery pack also you need a cooling system. So in cooling system, meaning the cooling plates are there, which takes the chilled water inside and then they take out the heat from the cells. So aluminum extrusion is very playing a big role into the cooling plates, either in the battery packs or aluminum castings, HPDC especially, into the motor controller power electronics, which gives lightweighting, cooling and all. And in motor controller, stator, rotor, there are people call it electrical steel, but actually it's a silicon steel, which has a low copper losses or mind. Yeah. And as Sanjay Aroli mentioned that India want to go into EVs. Rather, India is already into the EVs to a good extent. It's not a future, it is a present tense. And government from 2019, FAME 1, FAME 2, now it is PME drive, and it's also called as a FAME 3, PLI, meaning product link incentives, which are mandating the OEMs to produce locally so that our dependence, he already touched on that part, so I'll not go into more details. But what is mandating us or what is pushing us? One is a need, another is what is geopolitical pressures, is that we need to localize more and more. So like the silicon steel, aluminum, castings, extrusions, we need to really improve on that side. That is what the need of the hour and is going well and well ahead. I think I'll take other points later, maybe, or should I take it now? Up to you.
Maybe I have one question which has come to me for you regarding battery and this thing. So can you highlight on cell balancing concept and how it helps in increasing battery life?
Oh, very good question. Actually, the cell balancing meaning what is mean? Actually, battery pack consists of a number of cells. They are cylindrical, prismatic, pouch. It is just a form factor, but there is a combination of series parallel cells to get to the required voltage. Okay, and the required voltage meaning in cars we go about 300 to 400 volts, and buses 650, 700 volts. You know the P is equal to V into I. So you better your V, the I will go down, and hence your copper losses and all your weights will go down. Okay. So basically that V is derives the how many cells I can connect into series, and the AH or ampere hour how many parallel. Okay. Now what happens? Now I'll come to the balancing side. So you have hundreds of cells connected in series and parallel. Each cell is, while it is their best of class or world class quality, somebody mentioned WCQ, they are ahead of that. They are really very precision manufactured, but still there will be some variations in the anode cathode, some doping changes will be there, variation in the temperature, while I'm cooling them very well, but I can't cool every cell in the same degree of accuracy. There will be welding quality issues will be there. In short, there will be a variation in the electrical and thermal connectivities, which results into the variation in the cell to cell. Okay. And what happens is, let's say I'll take a lithium phosphate cell, which operates between 3.65, which is the highest one, and 2.5 is the lowest one. So I get a band of only one, and actually 2.5 is lowest, but normally we operate between 3.65 to 3 or 2.9 volts. So I get less than 1 volt, and in that my percentage of 0% state of charge to 100% state of charge is controlled. What happens if okay, in this, if I'm charging the battery pack, once the one cell reaches to 3.65, I say my battery is fully charged, and I say it's 100%. I don't allow other cells which are lower, still lower, to charge to 3.65, which is the highest, because if then the upper cell which reach first will overcharge, and I need to take care of the safety of the system. So in short, there will be variation in the cell voltages. We call as a delta V. V meaning voltage. Delta is difference between mean and max. If it is more, what will happen? Useful energy will be less, because I'll not be able to charge all cells to full, because I'm stopping at one. Others are still yet to. And while discharging, the lower one will discharge fast, and I can't discharge others also. My operating whatever available to me will be a lesser, and hence what will happen, usable energy will be lesser, and hence the range from the vehicle, from a customer point of view, he will get a lesser range. So that's why balancing of the cells is very, very crucial in the electric battery packs. So there are various techniques to balance them. I will not go into more details because others are there.
No,
But this
that's right.
is I just thought I'll
So
share this.
actually, I had one question regarding aluminum air batteries. How do you see their future in
Okay, excellent question.
auto?
Aluminum air batteries. Basically, there are various batteries, meaning nickel, NMC, LFP,
Yes,
and all this.
metal air
Aluminum air,
batteries basically.
yeah. So aluminum air, with aluminum is actually your is anode, which actually dissolves itself into the some liquid, or which you can again recharge them. But it is I'll say you cannot reuse it. It will
Yes.
have to recycle somewhere, and then, like in other
Mechanical
lithium and
recharging is required.
mechanical recharge, you will have to put again energy. So is a dissolvable or also sacrificing anode. I
Yes.
was just coining that word. This is sacrificing. So what was happening? This aluminum air battery, I worked personally on this project very extensively. Meaning whatever new, I always love to do that. I worked with this one of the Israel company. I don't want to take name, but I worked very extensively.
I know that.
That time, lithium and battery cells cost was about 120 dollar per kilowatt hour. Okay, now they are below or close to 50 USD per kilowatt hour. And our objective was, with aluminum air battery, we can be close to 40 to 50 kilowatt hour USD per kilowatt hour. So there are two challenges. One is on the costing side. Lithium has gone down very high, so the benefits are not that much. But on the other side, while aluminum air batteries actually are purely efficient from emission point of view, they actually emit the water out, water and some part of hydrogen. Okay, but they are actually in reaction, they generate a lot of heat. So in automotive, you have to take out that heat outside, which is one of the challenge. And also they are like a fuel cell. Is like a constant in a power source. You cannot fluctuate your power you need in a road. If you're going up a hill, or you're accelerating, or you're braking, you always need a variable power. So aluminum air batteries are very constant power, like a hydrogen fuel cells. They will deliver you like a very at constant rate. So that means you need another lithium-ion battery to take care of this. And this is like in hybrid, we call it a series hybrid or range extender. So this aluminum air will charge the lithium-ion battery, and the lithium-ion battery will drive the vehicle. So in short, the cost difference from a business point of view is not that attractive. Second, still you require a battery, lithium-ion battery. This is the in future, but yeah, you need to do work on on the heat management, especially in the car side, because it generates a lot of heat. And you need then refilling stations. You need to put that aluminum biscuits, take out the slurry from it. it is a lot of work there.
Right. So, yeah.
I hope
would
I'm giving answers properly. Otherwise, I go
Yes,
on.
because this was a question which is related to battery and EV and future of batteries. So I thought I just added that question at the
No
uh,
issue.
while you were talking. So that was not a actually planned question.
No issue.
But
I'm
thank
as
you
much
for
as I can understand, I
elaborating
can tell.
on that. That was great inputs. So I would like to move to the next the next point. I would like to ask Dr. RKP Singh from the component manufacturing perspective that he brings in. Uh, I know even I have got to know from RKP Singh sir that Bharat Forge is entering into EV in very near future within next few months. So they'll be launching some new vehicles. So we would like to hear about that also. But before moving to that, I would like to hear from Dr. Singh that from the component manufacturer's perspective, because that is at the heart of this entire evolution, and what new challenges are surfacing in various manufacturing processes, and from the EV perspective, and from the hybrid perspective, how these suppliers are managing the tight tolerances and other requirements. So I'm trying to combine two questions here. Over to you, Dr. Singh.
Okay, thank you. Actually, if you see the EV evolution totally, it was always guided by less emissions. And that is why there was two international committees, ULSAV 1 and ULSAV 2, which focus on light weighting, because there was a calculation that we reduce weight by this, emission reduces by this. Now today also, that is the key point actually. Today's EV, today automotive drive is totally dependent on emissions, sustainability, and a lot of automation, like automatic driving and things like that. So far component is concerned, the one thing is remarkable that steel percentage has reduced and aluminum percentage has increased in the electric vehicle. Reason being that the making vehicle lighter was having a challenge earlier in the IC engine, but now because of the heavy weight of battery pack, it become more urgent to reduce the weight. So aluminum components, if I remember in the era of IC engine, out of total weight of a automobile, only 3% was aluminum. Today, it has gone into double digit, definitely. I don't have exact figure. Maybe Sanjay might be having that figure. So we at Bharat Forge, we are gearing up with aluminum and steel component both. We have plant as a new plant on the aluminum component, which is already serving to electric vehicle like Tesla and all, located in Nellore. That is a die casting, high pressure die casting, where we are making maximum component for electric vehicle. We have also done innovative work in designing the e-axles, and 5 patents we have filed in this area, totally related with electric vehicles. So far mechanical components are concerned, it's not a big challenge because we can meet all the requirements. And as pointed out by other speakers, the temperature rise is one of the crucial things in the electric vehicle. So there the AC-DC converter and all these wherever heat generations are there and cooling is required, everywhere aluminum has taken over. And in the electric vehicle, the most crucial point today is the temperature control. And when we are launching our vehicle shortly, mostly in the buses and trucks, we are doing a lot of exhaustive modeling regarding temperature control, battery temperature management, AC/DC converter temperature management, or temperature management, things like that. So that is a challenge which we are meeting. And if you see the real challenge for the component business, it will not be from the mechanical component, because what has increased in the vehicle is the software. And today, the vehicle is threatened by two big threats. One is the semiconductor, 2 years back, entire vehicle manufacturing globally got down only because of one factor, shortage of semiconductors. That's why Government of India released such a big fund just to promote semiconductor production in India, because that is one thing. Second biggest thing is the magnets, because for making electric vehicle efficient, the permanent natural magnets are required, and magnets has got one rare element like neodymium, which is abundant in China and very less available in India. And we are trying, and so many people are trying to do research to replace neodymium to some extent by lithium, and not by lithium, by cerium and lanthanum. But then the question is efficiency comes down and weight increases. So one benefit leads to another disadvantage. So future also, even now the forecast is there that world can go again to a crisis of shortage of semiconductors for the electric vehicles. And another thing is that safety. If you see today, electric vehicle, all chambers and everything, it is so critical, the electrical wiring, the passing of the conduits, the all electrical. Any mistake anywhere can lead to very dangerous situation, and that is what is happening. If every 2 months, 3 months, there is not a news of electric vehicle catching fire, the sale of electric vehicle can go 5 times higher. If customers are holding up today that whether to go for it or not, is only one fear, and that is fire. So we are taking a lot of care on that, and we are working on two modes. One is that we are converting the existing IC vehicles to electric vehicles by taking from governments like UP government or any other government and agencies. Another is the total development of electric bus. So on the conversion side, we will be getting orders any time, maybe next month or something. And on the development side, we are working, but it takes time because there are a lot of safety issues and a lot of licensing is there. In the bus especially, licensing is very critical because it is so critical that we had to hire a vice president only looking for licensing, because you cannot bring a bus on the road because of these licenses. And that is required also because safety is the prime concern. So far component manufacturing is concerned, that drive and all this axle and all other components, we are already ready and we are getting order, we are supplying. Tesla is also our customer, both for aluminum and for other things. And our own product also, we will be using our components. But then other threats, and one question came, why India will become a hub and why China is a hub? The primary factor is the manpower cost and land cost, actually, because Europe and US cannot afford the manpower cost to manufacture the vehicles. Due to that, India will become the second hub, because both China and India is manpower surplus and technical young manpower surplus and all that. So that will drive the growth, and that is why India will get a lot of opportunity in this field, because those who will be shifting from China, their choice will be India, because India has got a lot of good infrastructure already available for component manufacture, for software, and young software companies are also very efficient in India, and India is moving quite well in the AI and ML also, which will be added feature in the future vehicles. Autonomous vehicles, I think still it will take 10 years for Europe, and I don't know how many years in India, because the uh, Indian mentality and Indian road movement, and it will be just a dream only, I think. So that is all I wanted to say. If any specific question is there, it will be okay for me. I will be happy to answer. Ruta, you unmute yourself.
Sorry, I was speaking. I didn't realize I didn't unmute. Okay, thank you. Thank you. These are really great inputs, sir, and real value addition we are getting from this, all the conversation we are having. Moving to the next but related dimension, I'd like to ask Udayan sir to share his take on materials and innovation in wake of this new trends in the automotive industry. So, how do you see what metallurgical or processing difficulties suppliers are facing or they are reporting, and as the material grades are becoming more complex, how everybody entire ecosystem is gearing up for that?
Sorry to interrupt you, ma'am. I need to
Yes.
go in 5 minutes. Is it okay? Because as I mentioned earlier, if any
Yes.
questions to me and then Udayan can go. Otherwise, I need to drop in 5 minutes.
Right now,
I
I
think
don't
that's
have,
fine. Ruta,
yeah,
you can
I
go
don't
ahead
have
with
any
your
questions anymore
questions.
for you.
Great, very good. Yeah, then Udayan continue. Sorry.
That's the reason I asked you the question which had come earlier to me
Oh, okay.
immediately.
Thank you.
So
Thank you very much.
you don't have to wait. Thank you.
Okay.
Thank you for joining, sir.
Thank you. Welcome.
Yeah, thanks, Ruta, for posing a different questions altogether to me. Yeah, if you look at really one of the challenges because of the EV that has come, and of course it was continuing with, rather I will say it was taken over from IC engine also. That is, the enhanced dead weight of the vehicle and how do we reduce that particular vehicle. So that is one area where people have been trying conventionally from high strength steel to advanced high strength steel, ultra high strength steels, etc. But I think we have to look at this problem a little innovatively. Like there are many components in a vehicle, which if I talk about the FEA language, they are undergoing the torsional load. And we know that in the torsional loads, basically whatever the maximum stress that comes on the surface, and as you move towards the core, at center it tends to almost zero. So this is the first principle what we studied probably in the first year of our engineering. Uh, can we look into that first year engineering and our current application? So in fact, in my tenure with John Deere and in my tenure with Tata Motors, we tried many components which were conventionally solid into a hollow structure. Even globally, Dr. Singh also may be aware that many crankshafts are being thought of, hollow crankshafts, which probably when I started my career in Bharat Forge, probably even we could not think of. So that particular perspective, a lot of innovative applications like many components, from conventional bar or forging structure, we could migrate to seamless steels, and there are many new generation processes which are being adopted even by Bharat Forge today, and like metal gathering and all those kind of cold forming and all those warm forging, cold forming, etc. Those kind of things. All these put together, the major challenge is, to address the higher stresses, higher loads, higher temperatures. Those are coming on the vehicle and component through innovative application, through innovative approach, right from the design stage. I think that is one area. But while doing that, the steel industry has to, work very closely with the automotive designers. So far, steel industry have been working in, not only steel industry, but this automotive domain, then this component manufacturing, then this other structures, they are going into the kind of silos working. Now we need to come together and come out with the different solutions. That is one part. Like typically, I will give you an example how the interdisciplinary approach is also required. A couple of years back, the zinc plating or the coating was considered as a entirely different entity. But then when it was required on the by the end user, steel industry has started migrating, and they have started, the coated steels are available in the market. Then off late, the green field projects have come up where the coating or the colored coatings have started becoming a part, and many domestic appliances like refrigerator or washing machine shells, they are all coming from the pre-coated and pre-painted steel. And it's not only one single tone, it's a multi-tone or multi-design kind of thing. So likewise, the another challenge which EV segment is going to face is probably a EMI, EMC, electromagnetic interference and electromagnetic compatibility. So like there are many motors are getting involved into it. Yeah, Mr. Chandekar,
Yeah, continue. After you.
Okay. So there are conventional methods, but people are trying to come up with these different kind of coatings to address this solution. One such company I know is HEF France. So can such coatings, agreed that they are not probably the core area of the steel maker, but can steel industry collaborate with such kind of solution providers and come out with steel which is probably compatible for EMI AMC. So that kind of requirement probably is one other area which I look that steel industry should think of. Also, on one side we are trying to go through the thinner and thinner sheets for the body in W, body in white, BIW, what we call our in our typical common man's language, the car body. But the limitation there is, though we are able to meet strength requirement and accident, crash requirements, etc. Now, as we become thinner and thinner, now it starts vibrating and probably can create the vibration and noise, vibration and harshness issues. So there, some kind of sandwich steels in a limited way it is available globally. So I think that is another area which I foresee as a kind of the steel industry can look into it. So these are some of the areas I think steel industry also need to look into it. And I think more such opportunities are there. So over to you, Mr. Chandekar. I think there's some
Yeah,
questions.
no. I just want to, ask one question to this expert panel. See, I would say steel man, I'm viewing all this. I am seeing that you are talking about hollow crankshafts. I am seeing you are talking about EV where the components are reduced from 150 to around 50 steel components. I am seeing that you are talking about thin car body, which will also reduce the steel weight. We are also talking about composites and aluminum parts replacing steel parts. So I'm just trying to estimate. We are estimating current, around 12% of steel goes into automobile sector. So as we go on with these innovations, how how steel intake for auto industry is going to reduce? To what extent? From steelman's
I can
point of
answer
view,
that.
this is my
No, I
interest.
can answer that.
Yes,
Okay,
please
I
answer,
can
sir.
answer.
आप EV
I
का
can.
बात करते हैं, you are talking about so many innovations in auto sector that will reduce our participation in auto sector. That's what I am visualizing. Please,
Okay,
sir.
okay. Just a minute. Hello. First of all, I will reply the development of hollow crankshaft. We have done complete project on development of hollow crankshaft with Fraunhofer and one of the national lab that is based in Durgapur. And earlier also it was tried, but there is a problem of vibration. Vibration increases, and that is why this has not been adopted. Whereas the hollow camshaft has been adopted, but not hollow crankshaft. Now your fear of getting weight reduced and aluminum share increasing and steel. My previous role, my job was concept marketing of steel, and I was trying
इंस्टेक
to
में थे ना
replace
सर आप?
aluminum and
You are
composite.
in charge of Instack, na?
Yeah, but I am telling you one thing. Answer lies that when he said coatings, coatings were having meaning when vehicles were used by the father and the son. Today, government regulation will be that after 15 years, vehicle will be scrapped.
Yes.
So since vehicle will be scrapped, you will have a lot of order for steel because these vehicles will not last.
Yeah, we
So
welcome
although
this
it will be
new
reducing,
scrappage policy. We welcome new
yeah,
scrappage
because
policy. We welcome.
see other countries were consuming more because they were making vehicle scrap. But in India, vehicle was going to 2, 3 generations, and there were no ban. They were just
Yes.
changing the engine, doing some boring of the engine and all that. Now that will stop. If government is serious, after 15 years, vehicle will be scrapped. a new vehicle will come that will increase the demand of the steel.
So is it 15
And
years or
coating
10
etc.
years?
has become irrelevant
Mr.
now
Pathak,
because
is it
vehicles
15
are not
years or 10
having
years?
very long life. It is 15 years as on date. 15 years.
I
15
also
years.
like
Yeah, I think it is.
to add little bit on this, Mr. Chandekar. I think we have to move, as you said, how steel industry can grow or whether it will shrink.
It will degrow.
Yeah. So
Auto industry growing, we will degrow.
yeah. So the question, I will say, I will put a different perspective to that.
Please.
Probably in terms of tonnage, answer could be yes, you will definitely shrink. But as I said, as I gave the example of, white goods, like for example, washing machine shells and refrigerator shells, etc. Some value addition, which has been done so far, collaboratively. So that probably automotive, this steel industry have to go a little aggressively, even thinking something beyond steel industry, which, has been, as I said, quote unquote, related to only metallurgy or steel making. So we have to go beyond that, and then probably in terms of the revenue, probably yes, you will still continue to grow. Maybe in terms of tonnage, you may shrink little bit, but I think ultimately the whole game of business is not the tonnage, but to gain money. So I think
No,
that
I understand, but I'm just asking whether, see, from 12% of today's consumption in auto industry, are we looking at something at 10%, maybe 5 years hence?
no. So that's my question is whether when you're talking 12%, is it 12% by value or is it
Volume. It
10%
is
by
by volume,
See,
obviously.
probably volumes will shrink
Okay.
definitely. But as I said, there has to be a demand and pull and push also both for value addition, and
Maybe
probably that
value-added
will
steel will have more.
yeah. So probably
space,
there instead of maybe there instead of 12%, you can grow to 14 or 15%. Your volume may shrink to 10% in terms of the tonnage.
Yeah.
But in terms
No,
of
but
the revenue earned,
the car number will increase more than 10%. The car number is also increasing.
no. So that anyway, I am talking about, sir, per car. I am not talking about the growth in terms of the numbers. I am
No,
talking
no, you
about
take
the
your
overall.
growth also into account. You take
Yeah.
your growth, I mean, auto industry growth also into account, and then
Yeah, of course.
apply the factors like hollow crankshaft and aluminum and composites and thin car body. So something will neutralize each other. These factors will neutralize with each other, or still auto growth will take us forward.
See, again, there is a two-way thought process that's happening in automotive industry.
Yeah.
On one side, when we were at the very high growth trajectory, suddenly Corona epidemic broke down. I mean, there was a Corona, and the whole lifestyle of the people have changed. And the people which were talking about the mobility solutions like Ola, Uber, blah, 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 Savari, and all those kind of things, people were thinking of, migrating from the individual cars to the shared car.
Yeah.
Suddenly, Corona came, and then there were so many restrictions as how many passengers can be traveling. And even let's say I wanted to hire Ola or Uber, I was not, I was scared who is sitting next to me, what are his or her, pandemic conditions kind of thing. That was one scenario, but once it has become normal, again, we are going on to the higher trajectory.
Yeah.
But at the same time, if you look at the transport situation in bigger cities, like say Bangalore or even in Pune or Mumbai for that matter, the traveling time has become the issue. Today, jokingly, we say that if all the vehicles in Pune, whatever are there, four-wheelers and cars, if they ply at the same time on the road, there will be no space for moving around. So the number of length of the vehicles have gone, but number of length of the roads have not increased. So those kind
But
of
sir,
challenges,
at the same time,
we
sir,
don't know what is going to override whom. That's going to be a major challenge.
Yeah, another
In
point
fact,
here
road
is
condition has improved. No, road conditions have improved. Today we are
earlier.
talking about I can think of going to Aurangabad by road. I can think of going to Kolhapur by road. But
Yeah, but
in
Mr.
Another point
certain
Chandekar,
years,
at
it
the
was
is,
same
not
time,
possible.
no, no,
I mean,
at the
it will
same
take
time,
a lot
Mr.
of time.
Sandekar, yeah, at the same time, Mr. Sandekar, we cannot forget that during Diwali, this Samruddhi highway,
Yeah.
uh, which otherwise is so-called desert, was, jammed because of the traffic.
Yes, yes.
The fuel on the all fuel pumps got exhausted. Even the hotels were dry with the kind of food or serving they were looking for. So again, if such kind of scenario, if incidentally you happen to be in one of those people who got affected because of that, probably you will rethink whether I should go by Samruddhi Highway or I should go for the public transport.
I did
So
use
that kind
Samruddhi
of,
Highway 2 months back. I
yeah.
did use, and it was a great experience.
so the another point
No,
here
I
is
traveled many times.
from the
I traveled
volumes
many times, but
perspective.
when it was a kind of standalone travel. It was okay, but at the time of Diwali, people who traveled, they say it's a nightmare. Or
Okay.
even when you enter the Pune or exit the Pune on the weekends, the scenario is very difficult. So I'm saying that dynamics today we really don't know. As an automotive person, I wish that my number of vehicles sold should definitely increase day by day. So do the steel will go. That's a wishful thinking, but at the same time, we also need to look into the real life situation.
So I was just going to add that earlier there used to be one car per family. Now there is at least one car per driver in the family. So, so number of cars per family has gone up. There are 2 cars per family nowadays, minimum 2 cars. So the volumes are going up, even if the amount of steel in one vehicle is might get reduced. So I don't see that steel is going to have reduced volumes in the automotive sector.
Good.
See,
Okay,
in particular,
I
Mr.
welcome
in
this.
Western
Chandekar,
countries, they are offering some concessions. Like, for example, when you travel with multiple occupancy, what they call HOV, high occupancy vehicle, they offer discount in the tolls, as well as there are certain lanes on multi-lane highways. Those are reserved for HOV kind of thing. But introducing such kind of I will say incentives have little challenges in India, considering our complex scenario and all that kind of thing. But yes, globally, if you talk about, the things are being taken place. Like they are high occupancy vehicles that where more than 2 people are traveling in a car, they are offered some discount in the tolls. And then, as I said, HOV lanes are there, which are fast moving, etc. So, but in India, that looks challenging.
As long as you make hybrid cars, it is okay for us because there will be engine parts and there is no reduction in weight as far as steel is concerned. But if you
actually,
make only EV cars, then it's a problem for us.
yeah, actually, Mr. Chandekar, I think you have put up very important question since we are in the steel world or steel.
Yeah, I see. This is
Yeah,
our
no, that's
perspective.
why. See, I would like to say something over here. Yes, steel industry should take this as a challenge.
Yeah, that is
See,
right.
what is happening in the future vehicle, it is going to be a multi-material vehicle where you have a possibility of using aluminum component as well as some of the composites, plastics and composites. Carbon fiber is also growing in a big way in some of the auto sectors components. Now, here, one of the things which can be advantage for the steel industry is like auto industry is always cost conscious. The manufacturing cost of a steel component is much more cheaper or it's much more lower than aluminum or polymer composite. At the same time, in the near future, we are going to get these ELV norms, like end of life vehicle. That is the recyclability. Of course, aluminum is recyclable, but steel is definitely recyclable. And the recycling cost of steel is much lower than recycling of aluminum. Polymer, yes, it's a tedious process for recycling. So if you consider all these factors over a period of time, the automotive industry also will start thinking and find different ways of weight reduction. Or, of course, they do talk about weight reduction. At the same time, you have safety norms. Those safety norms cannot be sometime made by just aluminum. Like for that, people like Tesla have to, I think, they have to build, and you can just imagine what would be the cost of that giga casting, what goes into Tesla car. I think Indian auto industry is not going to spend on that because we have to control the cost to customers. How much price customers can pay? They are largely from middle class. Most of the population who wants to buy a new car, they are just at the middle class or maybe slightly upper middle class people. So for that, affordability of such vehicles is also going to be a big issue. So immediately switching over to all aluminum or all polymer kind of a car, it's difficult. And particularly if steel industry goes with the development of ultra high strength steel, yes, in that case, it's really going to be a breakthrough for, I mean, the industry to continue this, because whether it's a hybrid car or hydrogen fuel cell car or IC engine car, there are basic components of body in white has to be something similar to steel, which has a high strength and which is crash worthy. So from those point of view, auto industry will definitely will have a good contribution of steel, particularly not just ordinary steel, but it will definitely go for ultra high strength, big hardenable, dual phase, press hardened steel parts, all those kind of technologies, because everything is technology driven and at the same time cost driven. So both can be matched. I mean, you are not just going to produce the same grades again and again. For that, one has to go for a different grades, which are other, I would say, a need of an hour.
Yeah.
So that kind of a development would happen in the steel industry.
We are already talking about microalloyed steel and integration. Mr. Pathak is aware that we were talking about integration of all grades into 2 or 3 grades for auto industry.
I can give you an example.
That exercise and that advancement is going on.
Yeah. See, I give you one example. While I was with Volkswagen, the body in white was made up of 36 different steel grades.
Yeah.
I think Udayan would appreciate, I mean, this kind of number. And yeah, we struggled almost for 7-8 years to localize most of the grades in India. And
not only localization, sir, in fact, reducing the number of grades and specification so that, steel manufacturing is also simplified. Steel production is also simplified.
Yeah, that is, but both things cannot be matched.
I know.
If somebody wants,
I will intervene here, Mr. Chandekar.
Yeah, please. I think we had a lot of discussions on this subject, Mr. Udayan.
There are two types of cycles which are, continuously keep on and off in automotive industry. One is, doing value addition, which Dr. Arora has said that for practically for every part or every major part, a special dedicated steel, now which gives value to that particular component and the cost. That is one part. Then, as Mr. Arvind suggested, there are about 67 to 70 different variety of steel. Then comes another cycle which says commonization, because it becomes very difficult for the procurement people to maintain or to manage these 70 varieties. So they come up with the idea that can we commonize from 70 to, let's say, 35 or 30, or even sometimes aggressive challenges are given, like as high as from 70 to 10. So those kind of things. So these both cycles, at least I have seen 2 or 3 iterations of such cycles in my career. That is one part. Another thing also I'd like to bring out to this platform is the change in governmental approach to the policies. Whatever government policies those are coming up, whether we like it or not, government is serious to implement those. I will give one small example. Almost about 10 to 15 years back, 10 years back, not 15, Mr. Gadkari, Honorable Minister for Road Transport, he came up in CM conference and told that I want to have buses which can run on 100% ethanol. And he threw a challenge open to the Indian heavy vehicle manufacturers. He said, don't worry about the cost, give me some N number of vehicles. I think some 10 or 100 he was talking about. Probably it was the first few years of the new government. So even everybody thought that it is kind of whatever the fancy idea that comes through the ministers and all that, which will actually never see the light of the day. So none of the Indian companies they developed any particular vehicle, but Mr. Gadkari has got the vehicle which is capable to run on 100% ethanol. 10 such buses were purchased from Scania. I think first 2 prototypes were free of cost, and then 8 vehicles were purchased, and those 10 buses were flying in different countries, in different cities in India. I have traveled through that bus in Nagpur, 100% ethanol bus. It was a green bus and all that, and I think it was somewhere in August 14. So government is that serious about whatever policy. Again, it can be a debatable question whether that is right, the government policy is right or wrong, whether it is, it should be, it should push forward and all or not. But at the same time, government was very serious. Another example I will give you is, when we talk about migrating from BS1 to BS2 to BS3, for every change in the BS in the emission norms, the major contribution or the major prerequisite is to have the right kind of fuel, which is controlled by government. Okay. Then when government has decided that from BS4 to BS6, they will not have the BS5 stage because the fuel was common. Again, the challenge was given to automotive industry that one particular day, the vehicle has to migrate to BS6. And the prerequisite for that was availability of fuel at least 7 to 10 months in advance. And one particular date was committed by government. Looking at the past experience, all automotive OEMs were in a relaxed mode that the fuel will not be available in time. So automatic extension of the timeline we will be getting. And to surprise of the automotive industry, the requisite fuel was available 6 months in advance than the date which was promised by government. So all the automotive OEMs were pushed to implement BS6 on the stipulated time, which government has initially declared. It created a lot of problems for automotive industry, but since there was no excuse available, it was being discussed. So what I'm trying to push upon is whatever government policies are coming forward, they are very serious about it, and by hook or crook, they are trying to implement it. I will not talk about the safety because that is another area. Again, the India has come up with the Bharat safety norms, etc. Again, that's a different topic, so I will not touch upon in the interest of time.
Yeah. May not be related, but just one thing. I think how much percentage should be included in the petrol is nowadays debatable question, isn't it?
No, 15 to 25%
Not really
ethanol will be
related,
only.
not really related to steel consumption, but still you were talking about ethanol, 100% ethanol.
Ethanol, I'm telling, policy is that maximum 25% or 15% is
Something
the
like that.
target.
Because otherwise it will reduce the mileage of the vehicle.
Yeah. But Chandekar, I make one last point for steel.
Please.
See, in the automobile, you are mainly representing the primary steel manufacturers, big steel manufacturers.
Yeah.
So there is one segment of big steel manufacturer like SAIL and Tata Steel and Jindal and all that. Other segment is the engine part, the main component part and all,
Alloy steel
which is
manufacturers.
covered by alloy steel. So alloy steel, we are one of the leader because we hold two companies, and we make all our steel mostly ourselves and we give to others also.
Yes.
Now only one company has come forward from the established companies is JSW to some extent. They have also entered the auto steel. So the primary steel manufacturers, they should not worry because their steel is mainly used in the body parts and structural parts and nothing else actually. That will remain in all type of vehicle, whether it is electric vehicle or this vehicle and that vehicle. Slight changes will be there. So main effect will be on the special steels. Like we will be losing business of crankshaft, but we are ready for that. We are more into transmission now. We are making gears which we were never making. We are making shafts, gears, and we are put new presses for that. So we were not doing cold forging. Now we are doing cold forging. So industry will go as per the demand, whether it is domestic or international, and will always be ready. And some of the product will vanish. Second thing is using high strength steel. Also, there is a limitation. If you go to designers, they will say I cannot reduce weight to that extent as you increase the strength because this young modulus doesn't change. And in their design, young modulus is the thing. So whether you change steel to this or that, they always resist that young modulus is not changing, bending moment is not changing, so many things. So more than 20% or 18% weight reduction by any steel is not possible because we have got a lot of experts here and they are doing this job only of weight reduction. But in the whole history, we have not been able to reduce weight more than 18% by replacing any steel. So you don't worry for steel consumption for main producer and for small alloy steel also. There are not many manufacturers, and but we are self-sufficient and we are meeting our demand and we are giving to others also.
And to add to it, sir, the many special steel manufacturers are also companies like Bharat Forge are moving away from auto industry. They are going to different applications. So to that extent also dependence on auto industry is getting slightly reduced, I would say.
It will happen because Bharat Forge is known for automobile components. Tomorrow it will be more known for defense equipment manufacturers than automobile components. In our business plan for next 5 years, the share of automobile has greatly reduced and share of defense and aerospace has greatly increased.
Yeah, so is the case with other special steel manufacturers. Their direct consumption in auto industry is slightly maybe reducing, but the consumption in the areas like windmill or defense, it is increasing.
Yeah,
I think Mr. Chandekar, I would like
to growing area for us.
Yeah, here I would like to give an example. At one point of time, the 3 out of 5 axles on American roads were made by Bharat Forge.
Oh,
so
great.
Probably that scenario will over a period of time will change, and probably every probably second or third windmill which is in US or the world-wise the weaponaries which are used, every third weaponry will be made from Bharat Forge. So that kind of scenario.
Yeah. But Bharat Forge also will change now. You will find that more artillery guns are made by Bharat Forge than anybody else.
That is good.
Yeah.
There is one question related to emissions which has come to me. So we were talking about having BS6 norms and getting employed. So from the Indian perspective where we have diverse traffic density conditions, whether copying European norms as is will help. So I think that question is to Dr. Arole. Uh,
Okay. See, basically, why do you think India would be copying European norms? See, it is not always exactly copying the norms. It is, I would consider it as a smart adoption of the European norms. The reason for that, the kind of technologies we use in our cars, those are almost similar to the European cars. And from that point of view, India is trying to adopt those norms. In fact, if I have to consider it, the India is now giving a more emphasis on safety standards, not just emission norms. Emission norms are just confined to maybe petrol or diesel vehicles. But now, yes, we are going to see
right.
nearly 25 to 30% of electric cars in near future. So from that point of view, what is important is the safety standard. And you must have heard this Bharat NCAP. So that is also undergoing a change, and that would get probably implemented sometime in 2017. And this will have mandatory features like electronic stability control. So, irrespective of it, whether it is required for European roads or Indian, but this is a specific requirement. Even the crash testing, yes, the crash testing is little bit different for Indian cars as compared to the the European norms. Then another is India is trying to make ADAS, like driver assisted system,
Mhm.
as a mandatory for those, and that probably I think it is coming right from near in 2026. It will first come for the commercial vehicles. They are also trying to have these autonomous braking systems. Even for the trucks, they are going to implement this emergency braking system. So these are some of the norms are going to get. If I have to talk about the emission standards, the emission, particularly for fuel or petrol or diesel vehicles, that goes with the quality of fuel, like Udayan said earlier. If there is a change in the fuel standard, yes, then there will be a change in the norms. So, like Bharat Stage 7, it's coming sometime between 26, 27, it will come. And yes, it is going to get aligned to Euro 7 because the technology, engine technology, and those kind of things are coming from Euro 7, and the fuel standards are also linked to Euro 7.
Right.
One of the reasons while I was in this fuel committee of BIS, that time we were considering the R&D or the development required for upgrading the fuels is much costlier. Then in that case, yes, the government of India, like all public sector fuel companies, they have decided they will adopt the technologies of European fuel industries so that it will be easy and cost effective for us to upgrade the fuels. So that's the reason. Okay.
Okay. Yeah.
Yeah, Ruta, I would like to add here a little bit that earlier when we were talking about the automotive performance, particularly Indian automotive vehicle, car segment particularly, we were talking about European driving cycles. Then
Hmm.
came the NED, earlier it was called EDC. Then came the new upgraded version, what is called as NEDC, New European Driving Cycle. But today in India, we have developed Indian cycle. And in India, there are two different kind of clear-cut categories. One is the city cycle and one is highway, and third one is the rural cycle.
Rural
So
cycle.
now we are becoming more and more,
Specific.
calibrated towards the real life scenario. Number one. Number two, because of the typical Indian scenario, in the electric hybrid vehicle, wherever there is a regional braking system, no, it was helping to charge the battery because there were multiple incidences of braking compared to any European country or any other country. So, though there are something odd in our traffic scenario, there are some plus points also we are getting. Like, for example, as I give you, the regenerative braking is generating more power and more
Right.
recovery of the power from the vehicle. So,
Right.
these kind of things are definitely happening in India also.
Okay.
Yes. Yeah. Any other questions anybody has? Otherwise,
No, I think
Yeah, better to close.
around 1.5 hours now.
Yeah. So better to
Yes.
close it because
yes. So this was today's discussion has clearly highlighted that Indian automotive sector is not just transforming; it is reinventing itself. We talked about many things, and it highlighted how rapidly the Indian automotive sector is evolving. So, as we move forward, collaboration across OEMs, steel producers, component manufacturers, metallurgists will remain essential to address the emerging challenges and tap into new opportunities. So, thank you once again and wishing you a productive continuation of the conference.
Thank you. Thank you very much. Bye.
Then, sir, you want to say something?
Thank you very much.
Yeah, thanks very much, all the participants and the panelists. It was a really insightful discussion with experts like you on the panel. So, and just one thing, we have done the recording of this event and this webinar, and we'll be shortly, distributing it to all the industry, and we'll share it with you also, so that you can also send it further. Thank you very much.
Thank you very much. Thank you.